Hey, we're here on the On.NET show, and we're...
Hold up. I'm the host.
Oh, geez.
Let me take this on. On the On.NET show today, we have Richard and Jose talking about .NET Core with IoT. Join us. Welcome to another episode of On.NET. Today I'm joined by Richard Lander, a PM for the .NET Core team.
Yep.
And Jose Perez, who's a developer on the .NET Core team.
Right.
And we will be talking about IoT with .NET Core 3.0 preview.
Yeah,
Right?
definitely.
What do you have for us today?
Well, we've been working on making it so that developers can write applications for these tiny little devices. It costs like $35 to buy one of these, and there's so much you can do. So we wanted to talk to you about that.
Perfect. That's a Raspberry Pi, right?
These are Raspberry Pi 3s. You may have heard that the Raspberry Pi 4s were just announced. Yes. Those, I put in an order for the pre-release order, but they're not coming until like August sometime.
Yeah.
So
I think they are already shipping, but they sold out very quickly.
I think that was maybe, yeah. The place I went to said it was pre-order.
I see.
But yeah, we don't have those.
Well, we still can make things work with the 3, right?
Absolutely.
Perfect.
So maybe I'll start with a few talking points.
Yes.
Yes. So let's get to the PowerPoint. Everyone loves that.
Everybody loves PowerPoint.
Yeah, and so Jose and I will kind of walk you through this. So the basic idea is this is a Raspberry Pi. This is kind of what it looks like, which you already saw. This is kind of what it looks like from a chip perspective. So the thing that says Broadcom on it, that's the actual chip. It's an ARM chip, and it's got 4 cores on it. And there's several variants that are in wide use. And they have like 1 point something gigahertz clock on them, and between half a gig and 4 gigs of RAM.
That's like 3 times my first PC in 2001.
Right, but I think the takeaway is these are no cloud servers. This is not what Azure is running on, for example. So you kind of have to think about your software a little bit differently.
Okay.
This is the whole space in which IoT lives. So the devices on the left, that black box, that Dell box, and also the Raspberry Pi, that's kind of what we're enabling with .NET Core. The devices on the right are important devices in this space, but .NET Core doesn't run on those. So it's just, we're not really competitive with those in any real sense, so we're not trying to beat them or anything like that. But this is just a way of thinking about the ecosystem.
Sure.
The Raspberry Pi has all these electrical pins on it, and this is actually what we're going to be talking about today. And they all have very different purposes, and we have APIs to program all of them.
Right. I think that's the difference with .NET Core 3.0, right? The fact that you can control the pins, unlike the previous versions where you didn't have access to those, right?
Yeah, do you want to talk about that, Jose?
Yeah, so basically, .NET Core in running on a Raspberry Pi, that's not a new thing. It's actually not new for 3.0 at least. But in this same 3.0 wave, even though it's not really part of the framework, it's going to be installed via a NuGet package. Okay. But we are building this new library that's actually in GitHub. It's open source in .NET IoT.
That's the repository.
That's a repo, the repository. And basically what that library will allow you is to be able to control these 40 pins on the Raspberry Pi. And that actually works with other boards or microcontroller boards, so it's not just exclusively for the Raspberry Pi. This is just the one that's most widely spread or used.
Yeah, and also it's, maybe you said this, this library will work all the way back to .NET Core 2.1.
Right, that's important.
Yeah.
Cool.
Technically actually to 2.0.
Right, but that's not in support anymore, so that's somewhat irrelevant.
So let's hit 2.1, that's the point forward, right?
Yeah.
Good.
Yeah.
Cool.
And one other interesting fact in there is right now we've just talked about Raspberry Pis, well the big one, but there's also like the Raspberry Pi Zero, so like the smaller model. And because our library that controls these pins is targeting .NET Standard, so that little Pi, that small Pi can't run .NET Core, but it can run Mono.
Right.
So our library will be able to run in there as well.
Great.
So we will be able to control like that. That little microcontroller also has pins, so we'll be able to control those as well.
And that one's $5.
Yeah.
Yes.
So that one.
I did order one
even
when it
cheaper.
came out.
Yeah.
I haven't used it yet, but I need to find a purpose for it.
I have one on my desk. Okay, so just super quickly, the basic idea here is that you can program these pins, and basically you're just sending electrical pulses. You're turning the pins on or off, and then depending on what you have, if it's something that's purely electrical, then it will turn the light on or off just from a pure electricity standpoint, just like light bulbs in your house.
Yep.
Other devices you can have on there, like this pressure and temperature sensor. When you turn the pins on and off, it's more like a data protocol
Right.
that you're sending. That you have to send it electricity as well, but that's more of a constant on sort of thing. And then you talk to it and say like, please give me the temperature right now.
Right.
Yeah, and then
So
you would
that's how
also
those
read
work.
from that device. So that device will send you data and send you the temperature, and so that you can
Yeah.
read it with the same light.
Yeah, so this is the most simple version of it, which is basically you have one wire that's coming up to this resistor. That's giving it electricity, and if that one pin is on, it goes through this LED, and then you basically make your way towards ground, and the wire on the farthest right is ground. So
Right.
this is just a simple electrical circuit.
Yep.
It's no different than electrical circuits in your house. And if that resistor wasn't there, the LED might like burst and shatter. Not actually. It just might burn out after a while.
Sure. Okay.
Actually, do you want to explain this?
The most simple circuit is just having an LED in the breadboard, as Rich showed in the previous slide. But as we can see here, it could also be very messy. You could have a lot of cables going on, and as Rich likes to say, Visual Studio is not really going to help you with this, even though it's very good at organizing code, but not cables. But anyway, so in the left, you can see a breadboard. That little red device over there in the middle of the breadboard, that's a temperature shield. So what's going on in here is that temperature shield is providing some data back to the Raspberry Pi. And then the Raspberry Pi is reading that temperature data and then passing it through another device that's also in that breadboard, which is an LCD display. So to be clear, like these two devices are not talking between each other. They're like the LCD is not reading the data directly from the temperature sensor, but your code running on the Raspberry Pi is driving both devices. So that is thanks to the .NET IoT repo.
Right. Like this LCD display, it's really dumb. Like it has no computational capability on it at all. Like there's no code that you could put on there to tell it, oh, just read from this temperature sensor.
Right.
Like it's just a stupid device.
Right.
Yeah.
Yeah.
Okay, so it'd be good to talk about why we did all of this work in the first place. There are really three reasons. One is we wanted to make it possible for .NET developers to create these kinds of applications. We wanted to make it so that companies that build IoT hardware could actually target the .NET developer market, because it's a very large one. It's one of the largest developer communities in the world. And the last thing is we have lots of friends in the Azure org, and they came to us and said, you know, we'd really like to make IoT work well and target .NET developers. So I guess actually this is a case of Microsoft targeting the .NET community.
Yep.
Right.
And so we've been working super closely with them to make all of these devices work well for their scenarios. So in terms of what we have in .NET Core 3 preview, obviously we have full integration with these Azure services like IoT Hub and IoT Edge. We support ARM32 and ARM64 across a variety of Linux and Windows versions. And we have Docker images for all of that stuff. So if you want to have like the container lifestyle,
Yep.
you can totally do that with all this, everything we talked about. We support all the device protocols. Yeah. And do you want to talk about these cool things that we've built?
Sure. So there's two main things that are built in the .NET IoT repository. The first thing is the actual library that's driving these pins. But the other thing that's built in there, it's a what we call device binding catalog. So these are like wrapper classes that use the IoT library in order to control more complex devices. So kind of like LCD displays or temperature sensors or pressure sensors or whatnot, like even motors or servos. So we already have a bunch of these device bindings already available in the .NET IoT repo. And here, like the example that we have in the slides they are just a color LCD display, and then the other one is an e-ink reader similar to the displays that the Kindle devices have or other e-readers. So we're able to drive those using these wrappers so that the consumers of our library don't really have to talk necessarily, like maybe they just want to drive a temperature sensor, and so they don't want to have to know all the protocols of how am I supposed to talk to this specific temperature sensor. Maybe we already have that binding in our repo, so they can just ingest, would be a different NuGet package, but they would just ingest this NuGet package and then just use a class called like temperature sensor dot read temperature or something like that.
So you create an abstraction for all the underlying implementation, so developers don't really need to know every single API for every single vendor, right?
Yes,
That's fantastic.
yeah, and it's a little bit like how when we started with .NET Framework, we provided these rich APIs over what was fundamentally P invokes into Windows.
Mm-hmm.
It's kind of the same model again. Some of the details are different. We also built these robots. That's another scenario that totally works. We have a set of libraries, so all of the GPIO and related APIs are in the system.device.gpio library. That's on NuGet. These wrappers that Jose was talking about, they're in the IoT.device.bindings NuGet package, and all the sources on .NET/IoT. One key thing to note is that the first package is like just a normal, supported by Microsoft package, just like system.collections kind of thing.
Yep.
This IoT.device bindings is a community-supported library. All the source is in this .NET repo, but it doesn't have the same level of support. So we intend to, continually both expand the number of bindings in it and also improve the quality over time.
Right.
But it is a community-supported package.
Okay. Do we have documentation that helps developers see how they can use it?
In the repository.
Okay, brilliant.
Okay, so that was the presentation. Now,
Excellent.
do you have any questions before we get down to demos?
No, I mean, I want to see this thing working, right?
Okay, so let's start with the first one.
Sounds
good. Yeah, we had to do a little bit of work to get this working earlier today. So let's obviously amp this up a little bit. So what we have here is, let's get rid of this. Okay, so what we're going to be doing is driving. This is really simple.
Do you want me to hold it?
Yeah, that would be good. So that's this guy, and this is called an LED bar, and so it's basically a whole bunch of LEDs that are all in a single unit, but you still have to drive them as if they were all separate. That's what all these crazy resistors are that are kind of like bent and crazy, because I've taken this with me to various places.
So this here is the LED bar. In case.
Right.
Yeah.
Yeah. Okay, so now what we should do is we should actually go look at this code. And I'm just going to quickly walk you through it.
Yep.
So what this is basically saying, here are the set of pins that are relevant for this particular program.
Yep.
You don't have to write your code exactly this way. This is how I choose to write it. For this particular program, cancellation is important. We don't need to go into too much detail on that. I created a class called Animate LEDs, and what it does, as you can kind of see here, is it allows you to create an animation over a set of LEDs. So I've got front to back, back to front, mid to end to mid, mid to end, light all, dim all at random. So these are all just little animations.
Like Christmas lights. I can use this one to
yeah,
control my Christmas
totally.
lights, right?
Definitely.
I had a particular thing in mind, and so I wrote all this actually incredibly simple code.
I see where you're going.
Yeah, and I'll just show you like the most basic one, which is, I don't know why that happened. Here we go. Front to back, all it does is it says, we can ignore this crazy stuff. Basically, it just says, do a sequence of 0 to the end. That's more or less what this says.
Okay.
And then sequence just says for each over this IEnumerable of pins, and then cycle LEDs, and then it just, what it does is, ignore the cancellation thing, it just says for each pin, put it high, and then sleep for lit time.
Right.
That's how long it's going to be up. And then it says make it low, and then sleep for dim time.
Right.
So it allows me to like create this animation where it's lit for a certain amount of time and then dim for a certain amount of time, and then it gives up and goes to the next animation. That's
Nice.
basically how that works. So how about,
Looks fairly simple so far. I mean,
yeah, actually first I'll run it on the Pi itself.
Okay.
That's this guy. And we were doing some crazy things before this. So LED bar graph, that's where it is. And I just happen to know everything about this one. So this is just where it lives. Okay. And there, and it's even working. That's always positive. So this is kind of like my kit display.
I don't know if you can see.
Yeah, I think we can see close enough. And then I have some console spew to say what's going on.
nice.
And then eventually, after I'm satisfied with it running, I just press Control-C and the thing ends. And the nice thing about it is the way the program's written is all the lights go off
Right.
when I press Control-C. Now, let's go back to, this box here, this terminal window, is me SSH'd into that particular Pi. So I have like a terminal window into the Pi, so I was literally controlling it from there. But let's control it from Visual Studio. And
Code.
Sorry, yeah, Visual Studio Code, that's right, yeah.
We both jumped on this
Yeah,
one, right?
don't put me in any
So
sort of...
you're running .NET Core 3.0 on Mac.
Yes.
Using code and
Yeah,
.NET
actually,
runtime.
let's. I'm going to run it just a tiny bit longer so you can see what's going on. So it's a very similar sort of experience here where you can see this console spew there. So now I am actually going to set this breakpoint, and then so this is this controller right is the primary call into the library that Jose actually built for us.
Right.
And so the cool part here is I'm going to press F11. I'm going to step into to that method, and now through the magic of SourceLink, if I can move this guy here. So if I hover over this, does that work? No, apparently not.
It doesn't show you that.
Doesn't show me. But this is actually...
You can see in the whole call stack. Right?
Yeah, so we're now in system.device GPIO DLL in this particular method.
Yep.
And so this file actually got pulled down from GitHub
Nice.
over the network. I actually don't have this code. Well, I kind of do, but not in a way that VS Code found. It pulled this code over the internet, and so now we can actually step through this. And so one of the things that was a very simple method call, so that's over.
No,
Actually,
it's not.
now we're into this other one.
Yeah.
So one of the things is that we actually did a show on this like a year ago.
Okay.
It was me and Peter Marku on the show, and we were showing somewhat similar things. And there we had some wrappers over some community native libraries.
Right.
And it turns out that those were not the best plan for us to productize for all these customers for two main reasons. One is they were all native code, so we couldn't have had this nice stepping in and stepping out with a nice C# kind of view, because you would have been in native code, and then you would have needed a C++ tool set, and all the craziness. And a bunch of that was GPL licensed.
Right.
And this is all MIT licensed, so you
Perfect.
can do literally whatever the heck you want.
And the important bit here is that if you find a bug as you step into things, then you can actually go and fix it and then continue doing it.
You can
while
fix
you're not
it.
leaving your...
You can fix it, or if you're, fairly sophisticated, you can, figure out what is the problem and then file an issue on the .NET IoT repo, and then Jose will fix it.
Or we are open source, so we will take PRs.
Yeah, totally.
That's where my mind went, because you find a bug, you fix it via pull request, and then you carry on with your work. That's brilliant.
Exactly.
It is. So this is working pretty well. One of the things we notice in general is we have actually a lot of C++ code in the overall product, and we've progressively been moving it to C#.
Okay.
And then when we do that, the level of community contribution for that component goes way up.
Yes.
So that shouldn't surprise
Not surprised. Yeah.
Yeah, no surprises. So that's kind of what we've been building. Now what we're doing is we're just making more and more, here's another display. We're just making more and more scenarios.
Okay.
Work.
Fantastic.
Yeah.
So we'll just see a lot more coming out in the coming weeks and months, and then hopefully by September, I think that's we should be seeing things stabilizing and going GA, right? So
Yeah, so we're technically, our calendar is kind of trying to align as close as possible to .NET 3.0.
Okay.
So we are, we have been releasing the same previews when .NET Core releases previews,
Right.
and we plan to do the same thing for GA. So
Perfect.
Yeah,
Okay.
that's the plan.
This doesn't sit up straight in any way.
Well, but it's still running and it's executing through VS.
What you need is a 3D
VS
printer
Code.
to print some bits there to hold it in place.
We actually have built, so we have this, it was too much to show on today's show, but we have this stand for these LED matrices that we built.
Right.
So there's 4 of them together, and we built a back for them. And some people on our team who are into 3D printing, they were like, yeah, that was a nice first try. Good try there, but you really need to 3D print like a real back to make it look professional and have a little place for the Pi to go to make it awesome. So we are actually headed that direction.
Perfect.
And then I
Maybe
won't
you can
get...
bring it to the show next time.
Yeah, totally.
Well, thank you very much for coming today, and hope that our audience found this useful. And I would like to encourage people to go and try out, and I think everything is on GitHub, right? So we'll put links under the video so you can go and find all the information you want. And
Yes, please.
Yeah, .NET/IoT is the place to start.
Right.
Excellent. Well, thank you very much, guys.
All right, thank you.
Awesome.